My name's Joran Viers. I am currently in private practice, but prior to starting my own consulting business, I did work for NMSU for about 10 years and then the city of Albuquerque for another 6 years, largely in the latter part focusing on trees. But with NMSU, I was a horticulture agent in an urban setting, so I dealt with a lot of different stuff. Trees have kind of become a bit of a focus for me, though, and so I'm very honored to be able to be part of this series and talk a little bit about good tree care. And I want to say up front that most of what I'm going to say about caring for fruit trees applies to trees in general. So any of this that you want to take with you and expand beyond just a fruit tree setting, please do so. So care and maintenance is really critical. You know, when you're talking about health, it's like human health or any other system, any other plant or animal system. A healthy individual is going to be less susceptible and less damaged by diseases and pests that might be out there. And so real key in all of this is what does it take to have a healthy individual? And that's really what we're going to focus on in this talk. In front of you right now on that title page, we have an old apple tree. This is in Washington State. I had the pleasure of taking a tour up there as part of a sustainable ag fellowship back when I was with the Extension Service. And we visited a number of different apple orchards up in Washington State. This is an old tree. It's about an 80-year-old tree. And it has been maintained every year, pruned, et cetera. So it's got, for a production tree of its size, it's got good shape. It doesn't have dieback and other problems. And it's a really beautiful tree. The problem for this particular grower is that this is a variety that was popular 80 years ago, and it's not so popular now. And so there's a lot of time and investment in this tree that doesn't really pay off real well. So modern orchards look a lot different. This is right down the road, same trip. This is how a lot of fruit production is done now. So what we have here are apple trees on fully dwarfing rootstock. The advantage of fully dwarfing rootstock is that it makes a small tree, which is easier to manage. The disadvantage is that the rootstock that makes it so small is so wimpy, it won't hold up the tree without support. And so that's what all of this steel infrastructure is. These are trellises to hold up these little fruit trees. And you can see how tightly they're planted there along the row. They're then trellised onto the wires. And you can go in and see how that wiring, et cetera, has really kind of become incorporated into the tree. And while in some senses that's not ideal, it's, damage to the tree, et cetera, in this production system, it works very well. And one of the other advantages to the commercial grower is that if this variety falls out of favor, most of their investment is in the infrastructure, not the trees. So they can go in and rip out all of those thousands of trees and replant with a new variety. And within a few years, they're back into a production mode. So for commercial production, that makes a lot of sense. A lot of us are more interested in a backyard level production. So this is actually my backyard. Picture taken a couple years ago. I bought the property about 2.5 years ago, and there were existing trees on the site. On the left is a cherry tree. On the right is a pear tree. And as we go through the talk, you'll see some things that I've done to make their life better. It was a little marginal when I bought the place, but we'll get into that as it becomes topical. So let's start with this. Trees are not hardscape infrastructure. And unfortunately, a lot of times they're treated like that. You just rip one out, put another one in, everything is going to be fine. But no, they're living organisms, and they are responding to and interacting with their environment. And that environment really, really impacts their health, just as it does with humans or any other living system out there. So this idea that, this Buddhist idea, life is suffering. Yes, it is, but that doesn't mean we have to encourage suffering. We can do things to eliminate some of that suffering. And part of that is just meeting basic physiological needs that the plant has. And in fact, any, again, living system has. Energy is required. Energy provides for growth, for maintenance, for repair of existing tissue that gets damaged, for reproduction. Water is the key to life. It is so vital in so many functions. And probably in our desert environment, water is our main limiting factor for tree growth. Also, plants, like other living systems, need oxygen, and this is at the cellular level. Every cell that is living is going through metabolic respiration, which involves breaking down sugars, releasing energy, and using that energy, but it takes oxygen. And we'll see where this comes into being important here in a little bit. So on the right here, this is actually my front yard. When I bought the place, that was one pine tree and colored wood mulch over fabric. When they make me king, I'm going to outlaw weed fabric, just so y'all know. That stuff is pointless and, in fact, detrimental to good soil development. So I planted actually a bunch of fruit trees. In this picture, you can't see them as well. They're still very young. This is the first year that after I had planted them. But a couple of things I'll point out is all of the plants around them, those are not weeds. Those are plants that I seeded intentionally. They are a orchard floor cover crop mix. So we've got a range of different legumes out there. We also have daikon radish, we've got oats, and a number of small flowered plants in the sunflower family. And they're building a healthy soil environment and a healthy above ground environment that's going to benefit those trees. You can also see some black tubing running across the ground, and that is the irrigation system that I set up for these trees. Remember, I said water is so critical, and if you're going to grow trees in this area, you are going to use water, and whether that's irrigation water from a well or an acequia, or in my case, it's city water, and my water bill is high, but that's because I'm using it to do this. So again, living trees, right? They're involved with all of their neighbors in different ways. And I think one of the most interesting things that's kind of coming into our understanding recently is that there is a social life that trees have. They interact both above ground through different kinds of volatile organic compounds that they release that are information traveling from tree to tree, but also through the fungal hyphae that connects all of those root systems in a healthy soil. So there's a lot going on there. There's some really recent research where folks were looking at the electrical signals that pass between fungal hyphae in the ground, and they shared that pattern with linguists, and linguists said, hey, there's 50 words right there. The pattern resembled language, human language, as complex as Russian or English. All right, so there are things happening that we don't understand. That doesn't mean they're not happening. Our lack of understanding does not mean they're not happening. Now let's think about that for a minute, though. We have trees that are connected across root systems that are interacting through that fungal hyphae network. But a lot of times in urban settings, the way we plant trees is they're very isolated. And so I kind of think of them as orphans. And I think a lot of the problems that we see in tree growth may have to do with the fact that the environment that they're in does not support a community, and that community then can support the tree. So let's look a little bit at those basic resources for life that the tree needs. They need energy. Where do they get energy? They make their own. They make it by converting the energy in sunlight, which is a radiant energy, into a stored energy in chemical bonds in simple sugar molecules. And they do that through this great process called photosynthesis, where basically you take carbon dioxide that comes into the leaf from the air, you take water that's come into the leaf from the whole vascular network from the soil up through the stem out to the leaf. And in the presence of light, those molecules are broken down and reassembled into sugar, and there's a byproduct, which is oxygen. And the oxygen is kicked out the leaf. So the reason that leaves look green to us, by the way, is that green wavelengths are the wavelengths that the plant is not using for photosynthesis. That's the waste energy in a way for that particular process. So that energy is reflected back out away from the leaf surface, and we see the green. So in that little diagram on the side there, again, we can just see the sunlight coming in, the CO2 coming in, the water coming in, the sugar molecule that's made, and then the oxygen that comes out as a byproduct. Water again, critical for everything going on inside the cell, as well in trees for moving nutrients from the soil matrix up through the root system out to not only leaves, but any living part of that plant that needs nutrients for whatever it's got to do. The other thing that water movement does, though, is it cools leaf tissue. You're getting evaporative cooling as transpiration is happening. And transpiration is simply water leaving the leaf because of tiny little openings in the leaf surface. The air is drier than the inside. Water moves from high concentration to low. But that movement of water and that changing of water from liquid to gas provides an evaporative cooling and keeps those leaves at a temperature where they can continue to function. All right, and I've heard this said, I love this. Trees are simply systems that interrupt and channel the natural flow of water from the soil to the air. And that's happening simply because there's more water in the soil than there is in the air. Water moves from high to low concentration, and plants and trees in general have figured out how to put themselves in the way of that movement and take advantage of it. So the water is coming in through the roots, it's leaving through the leaves. And that last little bullet there, roads and vehicles, I love to think in analogies because it really helps me to think about processes. So if we imagine water molecule as vehicles and roots as roadways, let's look at this diagram here. And what we see is that water is getting into the root system in the very small roots out at the periphery. This is like the driveway and the little neighborhood street. Nobody starts their journey out in the middle of I-25. But that's what we have at the base of the tree. Those big roots are moving lots of water picked up in the periphery, but there's not a whole lot of water absorption happening right at the base. And this becomes important when we think about how to water plants. A lot of times water is applied right at the base of the tree. And the tree has some fine roots there. It can take in some water, but it can't take in enough to really grow well. And probably you can't put enough in that small area of soil to really grow well. So that's the analogy. All right, oxygen. This is really only a problem at the root level, right? Because every other part of the plant is out in the atmosphere and can get all the oxygen it needs. But down in the root system, those cells that are needing oxygen so they can burn that sugar, so they can do the things they need to do, that oxygen has to come through the soil. And naturally, there's a little less oxygen in the soil than there is the air above. The plants are using that oxygen at the cellular level, and they're also giving off CO2. So if that soil can't breathe, we get a depletion of oxygen and a buildup of CO2 in the root system. And that then creates problems for those roots being able to function. And this last point is absolutely critical. When the roots are not working well, the rest of the plant is not going to work well. And we're going to come back to that idea right now. Roots are primary. I think of this in several ways. One, in time, if you've ever germinated any kind of seed, the first thing that comes out of that seed when it cracks open and starts to grow is the root. And if it doesn't kind of get started and start doing what roots need to do, then the rest of the process isn't going to work. But roots are also primary in function for the tree. And the way that I imagine this very simply is go cut down a tree, let it fall over, wait some time, a couple of weeks. What happens? Does the tree put down new roots? Probably not. Does the stump put up new shoots? Probably so. The root system is still there, able to keep functioning and continue growing that plant, whereas the trunk, once it's severed from that all-important root connection, is pretty much lost. Roots also are very important for keeping the tree upright. There's a lot of stress on a tree that's upright. There's gravity that's pulling it down and pulling branches down. There's wind that's moving it. And so in the trunk wood, we have a lot of fiber that kind of resists compression. But in the roots, we have long rope-like fibers that are holding that tree as it's moving in the wind, etc. And then right where those two things come together, at the bottom of the trunk, at the top of the roots, we have that root flare. And those buttresses are supportive as well. And they kind of transition from that compression wood into the tension wood. I've heard it said, I don't know where this number came from, 80% of tree problems, especially in an urban and desert environment like ours, are root system problems. That's almost always the first place to look to see what's going on. And here's again, just a side by side. The two smaller pictures, that's the same root ball from slightly different angles. And then the tree on the right, we already saw that a little bit earlier, but just to tell you what that is a young elm tree at the UNM campus. It's not a fruit tree, I know, but trees are trees to some degree. That tree needed to be moved. And so they used an air spade, which blows air at high pressure, supersonic volume air, and it just blows all the soil off the root system. And the beauty of it is, from a transplanting perspective, you can take a lot of root mass without having to take tons of soil along with it. And from the perspective of this talk, you can see what that root system ought to look like. Notice how most of those roots grow away from the trunk pretty much straight away. They don't do a lot of curving and turning. Looking at the tree, the stump on the left there, those two pictures, we see the consequences of leaving a tree in a container too long. The roots continue to grow and grow and grow, but they are forced into circles. Now let's think about water and nutrients coming into that tree. On the tree on the left, again, if I've got water and nutrients 5 feet away from the tree, they've got to get to that mass of circling roots, and then they go around and around and around several times before they go up. There's a huge inefficiency in that system. Also, that amount of root is not exploring a very big volume of soil. It has just gone over and over the same ground. And once roots are that big, they don't straighten out on their own. They're locked in that position. What is soil anyways? Well, it's mostly solid, mostly mineral, but it's got some organic matter. It's also got pore spaces where you can have water and air. And ideally, it's got a lot of living organisms down in there as well. Millions of microbes and tiny fungal hyphae and all that good stuff. And that level of biological activity in the soil creates a good rooting environment for the trees. So a rich soil is going to support more plant growth. As organic matter is deposited on the surface, either through just natural processes or maybe we put compost on there, all of those microbes, et cetera, can come up to the surface, pull that stuff in, and begin enriching that soil. So a lot of what I'm going to be saying today has to do with soil health, because if you don't have a healthy soil, then you are at a huge disadvantage trying to grow a healthy tree. You're left with trying to use rescue chemistry, and rescue chemistry is never as good as a healthy soil up front. Okay, and again, I'm kind of talking about urban settings, and this, I want to emphasize, this applies to your house on 20 acres as well if you've planted those trees right next to the house. All of the soil conditions that happen when we build structures apply to a structure built out in the middle of nowhere as well. So we've got compaction. This can be a huge issue. Compaction crushes soil, makes it more dense. That dense soil holds less water, holds less air, and is simply harder for roots to penetrate. We often have low nutrient levels, high pH, high salts, all of these things in those soils that occur around human activity. Now, we can improve that. We can do a lot of things to improve that, but most of what we do, unless we're focused on improving soil, actually harms soil. We also need to think about location a little bit. You know, are we in a site where that tree is not going to get enough sunlight, or maybe it's going to be getting too much? Maybe there's reflected light and heat if it's right up against glass windows on a south side. So there's a lot of things going on that we need to look at. The soil, too little space. This can be a huge issue, and we're going to look at some pictures that kind of describe what that space ought to be. This tree on the right, you might look at that and say, hey, it's got all the soil volume it wants. Well, not really, because unless that soil is irrigated, it's out of play. And this tree is not adequately irrigated. Under that gravel mulch are a couple of emitters inches from the trunk. That simply is not going to be able to get enough water volume into the soil, and it's not into enough volume of soil to build healthy soil. So that also plays into too little water, and then nutrient levels. When we have surfaces like this where we've got a mineral mulch, there's a weed fabric below that, there's really no way for natural processes to build soil over the lifetime of that tree. And then finally, that last point, I can irrigate the soil, but if it's extremely compacted, it's still not going to work for the tree. Very compacted soil simply is too hard for those roots to penetrate. And the soil texture you have does play into the compaction of that soil. A clay soil will compact more easily and to a higher level than a sandy soil, but you can compact a sandy soil to a point where tree roots will not grow in it. I recently planted some trees in a side yard that had a house had been built recently. They're still developing the neighborhood. It's a sandy soil. We had to use a pickaxe to break through that soil. So I'm really concerned. In the long term, I may advise those homeowners to have somebody come in, maybe me, maybe somebody else, with a trencher and run trenches through that soil just to break it up so that the roots have somewhere to go. All right. So I think I've kind of hammered on that a little bit. We're going to switch gears a little bit, and we're going to talk about the beginning of that tree's life in your care. The transition from a nursery setting, whatever that may be, to a landscape setting is one of the most critical points in a tree's life. We can fix problems and get things off to a good start, or we can compound problems and doom the tree. So first of all, we want to try to get good stock. And again, the roots being primary, we want as much as we can, we want to try to inspect them. That's difficult. They're in dirt. They're hidden. We can't see them. But what you do want to do is if you're buying a containerized tree, let's say it's a 5-gallon pot, a number 5 pot, before you buy it, actually dig away at the surface of the soil until you find the root flare. Because that root flare, when you're done planting, that root flare needs to be at the soil surface. And very often there is 2 to 6 inches of extra soil media in that pot on top of that root collar. So you want to be able to dig down to find that root collar, and then you also want to be able to look at the tops of those roots that are right there at the surface. Do they come out away from the trunk, or are they already circling right around the trunk? Some level of circling roots can be corrected, but if they've already kind of become woody and they're already tight up against the trunk, I would look at a different specimen before picking that one. There might be a better one out there. You can even take that pot and beat on it with your fist as you kind of rotate it to break the bond of the soil to the plastic, and then slide that root ball out and look for girdling, circling roots in the pot that it's in. Because we may have, again, maybe we've got a pot that's this big in diameter and the tree trunk right now is only this big. If I've got a circling root at the diameter of that pot, it's not going to be a problem until maybe 10 years out, at which point it's going to kill the tree. So we want to look for these things, because that transition from the pot to the soil is the one chance we have to get in there and address those issues and try to fix them. And the fix is to cut roots. Once they've gotten kind of woody, they don't bend very well. So trying to straighten them out and then dig a hole 4 feet long to accommodate that straightened out root does not make a lot of sense. Just cut that root before it turns, and new growth will come out away from the trunk, and new growth will come out pretty quickly. So you'll see as we go further planting, we often will prune the root ball, putting it in. You want to obviously look at the above ground part of it too, the shoot. You want to make sure it doesn't have dead branches in it, broken branches, obvious signs of neglect and abuse. Ideally, you want to find something that doesn't have 2 leaders that have a really tight union. That's weak and will often split in half and split the trunk. And certainly you want to pick species and varieties that are appropriate for wherever you are. NMSU, USDA, there's a lot of good information about there to help you pick that. Just because you like loquat, which is a semi-tropical fruit tree in the rose family, doesn't mean you can grow it here. So be aware for that. When you look at the site where you're going to plant, the first thing you want to think about is it compacted, and what do I need to do to decompact it? The harder that soil is to dig, the more compacted it is, and therefore the wider area you need to dig. I planted a tree yesterday in a yard that was super good soil, and I made a hole not much bigger than the root ball, because those roots will have no problem penetrating that good garden soil that we planted it into. But in other cases, I may want to break that soil up 2 to 3 times as wide as the root ball is, simply to make it easier for the new roots to penetrate out there. I may do some soil conditioning. That might be adding a little bit of compost. I don't want to add too much, because I don't want to change soil texture. I just want to add enough to kind of stimulate a little bit of that microbial activity, get a little bit of nutrients in there, and begin to kind of loosen up that tight soil. And then I want to think about how I'm going to irrigate. Am I going to be putting in some sort of a drip tubing system? Am I going to be flooding from a garden hose? What am I going to be doing? Just making sure that I can water a reasonably sized area under that tree. And it's my feeling that even when we use efficient systems like drip irrigation, we still need to water a wide area of soil in order for that tree to be able to root out well. So, a couple of emitters right at the trunk might get that tree through its first 2 to 3 years, but is going to be insufficient thereafter. I really, for fruit trees, I would almost always go mail order. Several reasons. One is the variety selection is much better. If you're buying from a local nursery, you're limited to what they decided they wanted to carry. And it's often the same few varieties that may do well here, but it's not a lot of diversity. So you can get incredible diversity mail order. You can get, old varieties that were discovered in somebody's backyard that have been growing for 200 years, whatever. You can get all kinds of fun stuff. You're going to pay less because you're going to be getting small plants shipped to you. So you're looking at maybe, with current inflation, maybe $40 to $50 a tree. They're going to be lightweight because you're not buying dirt. You're buying dormant trees. And thus they're very easy to plant. They're not heavy. You don't throw your back out moving them. It's easy to put that root spread the way it ought to go, so you don't end up with girdling roots. You can really get that tree to a good start quickly. Now they're small. You're not going to get fruit immediately. You're not going to get fruit for a couple of few years. So that's the trade-off. But in my feeling, there is definitely a false economy to buying larger trees. You are buying historical and hidden problems. And it's very often not going to come out well. Soil preparation. So here's one thought is, how much soil do we need? And I'm saying for most fruit trees, which aren't big trees, you're going to need a minimum of about 200 cubic feet of decent rootable soil. So a couple of thoughts on that. Decent. Trees don't need really rich garden soil. They're not a corn crop. They're not a broccoli crop. They're not going to be using a lot of nitrogen quickly. In fact, too much nitrogen may push growth at a rate that is faster than is ideal. Rootable. One, it's not compacted. Two, it's irrigated. So if it is compacted, you're going to have to decompact it somehow. You can do that by just digging it, breaking it up. You don't have to pulverize it. You just need to chunk it. You can also run a trencher or get a backhoe in to break up compaction. I don't recommend rototilling mostly for preparing soil for trees. It pulverizes soil where it does work, and you often end up with a little bit of a glazed compaction surface at the bottom of the reach of those tiller tines. They really tear up soil structure and deplete soil life. So what you want to do is break it up roughly. You don't want to pulverize it. Break it up roughly, get a little bit of compost in there, kind of let that settle in channels and pores and stuff, and that's going to turn out really well for you. You may want to get a soil test done. It's going to tell you what some of your growth limiting issues may be. You may have high salt levels, high pH levels, insufficient potassium or phosphorus. All of those things can be looked at. Soil tests are not great at telling you your nitrogen needs or resources, because nitrogen moves through the soil very quickly in peaks and valleys, and so you can tweak nitrogen more easily. If you have a really poor soil, maybe consider spending a year trying to condition it before planting into it. And I'm gonna talk really quickly about a wonderful experiment that was done a couple of decades ago at the Morton Arboretum near Chicago. A researcher planted a number of trees. He was looking at the effects of mulch. And we're going to come back to that in a moment. But he had his experimental plot. Some of the trees, the control was just water on bare dirt. And then they had synthetic nutrient enhanced water on bare dirt. They had compost tea applied to bare dirt, compost applied as a mulch, so it wasn't bare dirt, and wood chips applied as a mulch, no bare dirt. And for 2 years, they monitored both tree growth and soil nutrient levels. The take home was that compost as a mulch absolutely did the most to improve soil nutrient levels, no question. Wood chips as a mulch did not improve soil nutrient levels much at all. Wood chip as a mulch promoted tree growth better even than compost. The decaying bodies of old trees on the surface create the conditions under which tree roots evolved. They evolved in soils being conditioned by the organisms that break down organic matter, woody organic matter at the surface. And so my take home from that was, again, I don't need a rich garden soil to grow trees. I need it to be uncompacted, irrigated, and have access to organic matter on the surface that then can decompose. All right, planting. Lot of points where we can either set things up well or not when it comes to planting. So one of the keys is don't plant too deeply. This is probably the most common mistake made with planting trees. People either want to plant them deeply so the roots will go deep, or they want to plant them deeply so that they don't blow over, any number of reasons. But if you look at naturally growing trees in a forest environment, and you pull away the duff around them and whatnot, almost invariably you'll see the root flare at the soil surface. Much like in this drawing right here, that transition zone between trunk and roots needs to be at the soil surface. When we plant it too deeply, we basically make the tree live like this, and it's got to spend its whole life with its, just, it's not, no, let it relax and reach out. So don't plant it too deeply. In fact, if you're buying a containerized plant, what you want to do is you've pulled away the soil from the top to figure out where that root flare is. Now measure the distance from the bottom of the root ball to the flare. That is how deep you will dig your hole, no deeper. Okay, but you want to dig it wider, because what we're wanting to do is encourage root growth out away from the tree. And let me just reiterate, I don't think I really stress this enough. Roots are horizontal phenomena. They like conditions in the shallow soil. Everything they need, oxygen, water, nutrients, and a density that they can penetrate, is better in the shallow soil. You'll get some deeper rooting in some conditions, but don't think that you can force roots deep by planting them deep, or by putting the water in the soil 3 feet down. Roots are shallow. That's how they function. So don't try to change that too much. The hole, again, should be wider than the root ball. They say 2 to 3 times. Now, I went to a talk once related really more towards the commercial landscape industry, but the gentleman was talking about planting and making the point that, I can tell the planting crew, dig a big wide hole, pull all that dirt out, and then put it back. And the minute I turn my back on them, they're not going to pull all that soil out of the hole just to put it back. They don't need to. If they make that hole wide enough, and then rather than dig the soil out and put it back, just break it up in place. Just take a shovel, a pick, a digging pitchfork, something, and go around that root ball and just break up the soil. We're just trying to loosen it in a way that roots find channels to penetrate and get out away from the trunk. There's another little picture here. And by the way, you may have noticed some of the pictures in this talk, I credit who the image is from. If it's uncredited, it's my own. So this is my own. This is my drawing of planting a bare root tree, a little bare root fruit tree. I can settle that root system out right there where I want it to be. The curly scribbles on the top of the soil surface, that's mulch. And I've taken a little bit of dirt from the hole and made this berm at the edge of it, so that I can water it simply by dropping a hose into the mulch and letting it fill that basin. And that's going to give water to the roots where they currently are, so the tree can take it in and live, but it's also going to pre-moisten the soil adjacent to where the roots are. Roots grow where there's water. They don't grow through dry soil to get to water that they sense at some distance. They don't have that ability. They follow moisture. So we want to lead them with moisture. All right, avoiding and eliminating circling roots. I mentioned this already. Very, very common problem, especially with container grown trees. And the larger that container, the more likely to have hidden levels of circling from smaller containers earlier in life. So again, buying large trees, you may end up buying a lot of hidden problems. This picture is showing boxing of a root ball where they just make 4 cuts and square off that root ball. The idea is there's roots, and you can see some of them down here in the low part. I don't know, is my cursor visible, Miranda? Okay, so right in here, you can see those fine white roots along the edge. White is living. Those are healthy roots, but they're turning. And so the idea is to just cut them, and then new growth is going to be able to come out away. I don't necessarily box them. I'll usually make more like 6 to 8 cuts and keep it more rounded. I will often cut something off the bottom. Very often there's a mat of dead roots at the bottom, especially if it's been overwatered for some period of time. And I'll kind of shave the top as well to expose that new root cut surface to where it can grow out well. And then, yeah, if we're cutting roots smaller than an inch in diameter, they will put out new growth very readily. As you get into larger and larger roots, they are less able to put out that response growth. And so we like cutting small roots if we have to cut roots at all. Once you've got that tree planted, let me make sure I didn't skip anything. Yes, okay. So you want to water it frequently initially because the roots are still in the confined space that they were in a container in the nursery, where they got watered daily or at least every other day. And so until they've kind of occupied a bigger soil volume, they still need to be kind of pampered. But you're going to want to iterate that to a less and less over, that first season. So initially, you may go ahead and water it every 2 to 3 days. But then you want to look at the tree. If it's drooping, if the leaves are drooping, then the leaves aren't getting enough water. Before you water again, feel the soil. It may be wet. And the reason the leaves aren't getting any water in is the roots are too wet to function. There's no oxygen available. In that case, you'll need to let it dry down. But more often the case is that the soil needs more water. I don't recommend staking trees as a rule. If you plant it well, that root ball is a pretty stable system. And once it starts growing out, especially if you haven't planted it too deeply, you're going to get good pinning from that root system. And you want that trunk to be able to move in the wind. If the trunk doesn't move, that tissue is never stimulated to add strength to resist movement, right? So if I stake a tree really well, I create a tree that I have to keep supporting. If the tree is really wobbly because it's already really thin, then I might stake it a little bit to pull it back, but I still want to have the ability for that trunk to move and get the signals to thicken up down below. Mulch is great. Mulch is anything that blankets the soil surface. It could be old blankets. It could be chipped up tires. It could be rock. I don't recommend those last two, by the way, but they are mulches. Anything that blankets the soil surface and cools the root zone below and slows down evaporation of water from the soil directly to the air. Now, that said, not all mulches are equal. And my complaint with both mineral mulches like rock and things like synthetic tire or chipped up tire, these products, first of all, they don't break down in biological time in a way that benefits the tree. Rock breaks down in geological time, and 30 million years from now, that might be a really good soil based on the rock mulch we put down, but I am not going to be around to see that. Chipped up tires, why would you do that? Why would you put that toxic material over a root system? Both of those also convert sunlight into heat. Now, that heat isn't penetrating into the soil. The roots are still cool. That heat is rising through the canopy of the tree, stripping ever more water from those leaves. So I like an organic mulch. Chipped up trees is one of the best mulches. Old spoiled hay, old leaves, any number of things like that. Bark's okay. The real advantages of organic mulches is that they break down over time quickly enough to feed the soil, and they don't heat the air above. And we're going to look at that living mulch concept here in a moment in more detail. I would not fertilize in the first 1 to 2 years. I know in some commercial production systems with fruit trees, they'll start fertilizing right away to push them into production. Those trees are not grown for longevity. They are grown for quick production. And I would rather let that tree kind of get itself established and feed the soil and let it grow at a decent pace. And then once it goes into production, I might start adding nitrogen to the system. Some people will paint trunks with white latex paint to get around sun scald. I have both done that and not done that. More recently, I've not done that simply because I'm lazy. And most of the trees I have not done it to did not develop sun scald. It's not a given. But what that sun scald is, basically in the winter, the tree is dormant, but that thin and often dark bark absorbs sunlight, warms up, kind of starts things moving, the sap's flowing a little bit, and then that night it freezes, and that expanding sap breaks cell walls and kills cells, and you'll get strips of dead bark on the south and west side of the tree. Painting it white simply reflects the light. It doesn't warm up. That last bullet, again, the little fruit trees that are right outside my window here in the front yard, this is their second year. Some of them did put on a decent fruit load. I picked it all off. They're too young yet. Again, analogies. Those are 13-year-old girls. They do not need to be carrying children and raising and giving birth. No, let them grow some more. So prevent that. That said, I did leave 2 apples on one and a couple of peaches on another because I want to see what they taste like. But I didn't leave everything. I just left a little bit. So now we've got it planted well. We got a decent soil. It's mulched. We figured out our irrigation. The tree is growing. All is good. Keep that irrigation schedule going. We often recommend watering even in the winter when they're dormant, maybe once a year, just because our environment is so dry. In other places, that winter watering is not recommended. I kind of like the idea of doing it here. I think it helps. As the tree is growing, the irrigation needs to grow. The footprint of that irrigation should grow as well. And this is where we run into trouble with drip systems, is that very often no thought has been given to how that's going to be expanded over time. Flood irrigating a field, that's great. Everything's getting watered. But if you're applying the water very metered and carefully, you're going to want to think through how you do that. Structural pruning. We're not really going to talk a lot about pruning. It's a whole nother seminar series in and of itself. Structural pruning is the pruning done early to the tree to develop the form you want. With fruit trees, that may be an open vase form for your stone fruits, your peaches and whatnot. Or it may be a single leader or a modified single leader for apple trees. But whatever it is going to be, if you can do that pruning while the branches are small, the wounds you make are small and much easier for the tree to deal with. So you're not having to go back in and make big wounds that may end up inviting decay into the tree. Keep the mulch there. Don't let the trunk get damaged. Again, the picture, this is not a fruit tree, but this is from my time with the City Park Service. That's a tree we planted the year before. The second year, the mowers have already pretty much killed it. They have doomed it. All of that bark that's been peeled off, you have to understand the bark is a very important protective layer, and what it's protecting is this thin ring of regenerative tissue called cambium. And that's where all new growth comes from, that thin green ring right under the bark. And when this happens to a tree, we have shut down the ability for that tree to grow that part of its trunk. And it's, yeah, lots of problems. I don't recommend, again, rototilling, especially within the root zone of established trees. Rototilling is fine as a one-time operation at the beginning of setting something up, and it's less of an issue, I would say, for vegetable garden beds. But even there, I rototill them initially, and then every year after that, it's hand tools, because we're learning more and more about the importance of soil structure, and that is wrecked when you rototill. You just pulverize it and turn everything up, and it's not good. So these established trees, again, if you just bought the house, there's trees on it, you want to take care of them, what are you going to do? Well, consider the root zone and the irrigation to that. And, is that something I can improve? Can I expand that? Does it need to be expanded? Pruning needs, you may need to give yourself a 3 to 4 year plan for stuff that's overgrown. We'll see a picture here in a moment. If you are pruning for size control, do that during the summer. The trees are at a state in their annual cycle where they're doing more maintenance than new growth, and so you don't get as much response growth to the wound. And the wound itself, the tree has to seal it up, and the things it does to seal it up are more easily done when the tree's fully awake in a maintenance phase. So summer pruning. Stem girdling roots. The picture, again, not a fruit tree, this is an ash tree, but what I want you to notice is how the diameter of the trunk suddenly begins to decrease right before we enter the soil. This is not good. This tells us there's a big, thick root of the tree's own making, the size of a pot that the tree used to be in, that is underground there. And what that's going to do is it is going to crush the ability of the tree to put new rings on. And if it can't add annual ring growth, its vascular system is crushed. And so you end up with a tree that has drought stress in the canopy, no matter how much you water the soil, because there's a choke point and the water can't make it past there. Sometimes I'll take a wood chisel or a pruning saw and remove stem girdling roots. But if they're of any size and they're already embedded in the trunk, it's probably just an academic interest. This is what's killing the tree, and there's really nothing to do about it. All right, soil improvement options. So back to my backyard. This picture is from a couple years back. Like I said, when I bought the place, there were some fruit trees out back. This is one of them. It's a little pear tree. Now, the previous owner had an irrigation system. She had taken a 1/2-inch poly tubing, buried it underground, and at every tree she planted, she popped it up above ground and poked 2 holes in it. So the trees were getting water, but they were not getting a big footprint of water. It was right there at the trunk. And so I came in and set up a different system. And you can see it here where the water is coming up from the buried line right here where my cursor is. I've got a little valve here so I can turn it on and off. And then all of that brown tubing is drip tubing. Every 1 foot, there's an emitter that puts out water. So all of a sudden, the water footprint for this tree has changed from 2 points right near to the trunk to, I don't know, 20 to 30 points all around the canopy and out beyond the canopy. And we're going to look at that again in a moment. In fact, I think, yes, here we go. Same tree this year. Notice a few changes. One, I went in and I put various plants in the understory to also use that water and to provide for a communal root zone, which I believe benefits the tree. So we got mint in there, we got lavender, French tarragon, and echinacea, and they're all growing happy in there. The tree has more than doubled in height in 1 year because of that improved irrigation. Now, you may notice it looks a little bit yellow. For whatever reason, these pear trees, I have 2 of them in my yard, and they do tend to be chlorotic. And so I'm treating them with a little bit of a micronutrient fertilizer to address that chlorosis, but I haven't really figured out the key to why it's happening. It may be, as we go down here in this soil improvement options, pH. pH is the relative acidity of the soil, and it affects the availability of nutrients. And the thing with pH is that it is what it is. You're not going to change it, not over any length of time or any space of soil. You can tweak it temporarily, but our water is alkaline, our soils are alkaline. It's just going to tend back to that point. So again, it's my feeling that even at whatever pH, the more biological activity in the soil, the more those nutrients are becoming available. And then I can also use a micronutrient fertilizer to address some of that. Vertical mulching. This is a cool idea. Basically, if you've got an established tree with hard pan soil around it, you just make holes all around that root zone and you backfill them with compost. And now you've created channels that water can more easily penetrate into that soil, oxygen can more easily penetrate into that soil, and you've got some nutrient flow happening in that soil. And there's some chance that you'll damage roots, but you can see the pattern up here where they've just kind of done circles around the tree out to the drip line and a little bit beyond. And here's another thing I really want to drive home. An established tree that has a decent footprint of moisture in the soil will have roots well beyond the canopy. We talk about the drip line as kind of an important point to water, and I believe it is, but I think it's the middle of a broad zone that goes both towards the inside and towards the outside that should be watered to get that tree the water it needs. Again, using my own backyard as an example, you can see here another of the trees that each of these had one line with 2 holes punched in it. And now all of that circling tubing on the soil surface is drip tubing. And it's all able to water at once. What I've done since putting that in is I've sowed the orchard floor cover crop mix back here as well. And we'll get to why that is helpful in a minute. Okay, consistent available moisture. This is a lovely slide I stole from somebody else who stole it from somebody else, but it talks about how the architecture of a tree really is. So the wine glass is the canopy, the stem is the trunk, and then the whole dinner plate underneath there is the root zone. Okay, the roots are broader than the canopy is broad. There's more mass above ground than there is below ground because it's thin. It's a shallow horizontal mass. It's not a deep mass. But it kind of talks about how that architecture is. And, you know, when we water down here in this middle picture, hydrate the dinner plate. Don't water just the trunk, water that whole area. And if the tree has consistently in the past only been watered close, watering that broader area initially isn't going to have an impact because the roots aren't there yet. But if I don't put water there first, the roots are never going to go there. So I have to lead the roots with water. Organic mulch. So I've already mentioned this idea that tree roots, generally speaking, evolved in soils that are being developed and conditioned by old tree parts on the surface slowly decaying away. And one of the key components of that whole soil ecosystem is mycorrhizal fungi. If you haven't heard of them before, you need to. These are fungi that form beneficial associations with trees. And in fact, the fungus will enter into the roots all the way into individual cells. but then it's way out into the soil as well. And the fungus is really adept at picking up water and picking up nutrients and bringing them in, and then it trades them to the tree for sugars that the tree has made through photosynthesis, which the fungus needs to feed on. So it's a beautiful symbiotic relationship. Organic mulches also provide some level of weed suppression. There is really nothing that provides complete weed suppression and is still worth doing without killing soil. Some things, bindweed. I mulched one time in an orchard, probably 8 inches deep with wood chips, and that kept the bindweed at bay for 1 year. For the next 2 years, it was the lushest carpet of bindweed you could imagine. But the bindweed didn't get up into the fruit trees. The mulch decomposed, the bindweed went away, and all of the old pasture grasses came back. And so I thought that was a good result. Inorganic mulches. Again, I've mentioned this already. Anything that blankets the surface is going to cool the soil and is going to reduce evaporative loss, but they're not all going to provide the same level of benefits. There may be a heat problem, there may be a lack of nutrients. And then the weed fabrics I already mentioned. When they allow me to be king, I'm going to outlaw it. It's awful. Look at any established landscape where weed fabric and some sort of a mulch was put down more than 3 or 4 years ago. And unless they're out there chemically treating it, it's already full of weeds that are growing on top of the fabric. So they don't work as advertised. All right, living mulches. Living mulches are a great idea. These are typically perennial, they may be annual plants that are forbs. They're not woody, they're growing under the canopy, and they're adding some benefits. So a lot of the species in the mix that I used are legumes. They are pulling nitrogen out of the air and adding it to the soil. And so the trees are getting some of their nitrogen needs from their companions. The daikon radish I mentioned, that penetrates deeply, breaks up soil, brings nutrients up, helps dissolve or do away with compaction. And then there's a bunch of small flower plants, and I mentioned 4 plant families in particular: the sunflower family, the carrot family, the mint family, and the pea family. All of those small flowered plants are extremely attractive to beneficial insects. Many beneficial insects that control our pest insects are carnivores as larvae, but vegetarians as adults. They're nectar feeders. So if we don't have something for the adults to eat, you're not going to sustain a population. And here's the guys we're trying to sustain, right? We've got jumping spiders. Now, let me back up and say a lot of our beneficial insects are as likely to eat other beneficial insects as they are to eat pest insects, okay? That's just how it works. Spiders being an example. But man, I love spiders, especially jumping spiders. They're really cool. Praying mantids, they'll eat anything they can catch. Hummingbirds, I've seen videos of them catching hummingbirds at hummingbird feeders. I saw a video of, I don't know how they did this. There was a praying mantis that was next to somewhere where somebody was doing metal work, and there's all these sparks flying, and the praying mantis is in there battling the sparks. They're just bad. There's nothing they won't attack. Assassin bugs, named because they have big stabbing beaks that they'll puncture another insect with and suck out their juices. This is a new hatch. Probably half of them are going to eat the other half before they make it away from the hatch site. But again, that's just part of nature. Ladybugs, gotta love ladybugs. And in my little orchard out front last year, I had so many ladybugs, just almost a nuisance amount of ladybugs. It was great. The adults do eat aphids. They're one of the beneficial insects where the adult is also helpful. The larvae you can see here on the right, they're like little Gila monsters in appearance. They're just so ugly. They're really cool. And man, they love aphids. They eat them up. Azu hoverfly larvae. These are maggots, right? Fly larvae are maggots. Well, these are maggots that exist in a drier environment, and they crawl around eating aphids. And then finally, on the right-hand side here, you can see some of those aphids are kind of big and golden looking. Well, those are hosting parasitic wasps. So the tiny wasp lays an egg inside the aphid, and it's kind of like the movie Alien. The aphid doesn't die right away. It just exists while this larva eats it alive from the inside. Lovely stuff. All right, fertilization. If you've got a healthy soil ecosystem developing and a decent starting soil to begin with, you're probably not going to need a lot of fertilization, especially early in the life of the tree. Once fruit trees come into production, it may be useful to add a periodic dose of nitrogen. And what I had heard that I liked was the idea of, you kind of determine what that nitrogen need is going to be. There's some good sources. NMSU has some great sources on helping you kind of figure out what that might be. Whatever it is, give them half of it at the end of the growing season. They will absorb it without pushing growth, and it'll be there ready to support the early spring growth. And then the second half of it, reserve until you are sure that your crop has made it past last frost. If it hasn't, you don't need that second part of the dose. The tree doesn't have any fruit to mature or very few fruit to mature. It doesn't need that extra nitrogen. Compost is a great way to add nitrogen to a system. Legume understory, white clover, New Zealand white clover is a great one. And then synthetic nitrogen can be useful, but in some cases, if it's over applied, it actually tends to throw the natural soil microbial population out of whack and reduce the ability of the soil to provide that nitrogen. You may need a soil test to look at, again, some of those things that may limit growth. Most of our native soils have sufficient phosphorus and potassium. There may be an issue. You may have a salt issue. If your salts are too high, it's going to impact growth. That can be addressed by simply flooding that soil with so much water, it dissolves the salts and carries it down below soil level. That's a lot of water, and it's probably going to have to be done every year or a few years. And the water itself may be the source of the salt. pH, as I said, there's really little you can do to change pH. So what you might do is look at things like the micronutrient fertilizer I highlight there, the Sequestar iron 6%. The form of the chelate makes a difference. So this is chelated iron. A chelate is simply a molecule that holds another molecule, okay? So here's iron in the plant available form, but due to pH, it's like this. Plant can't take it in. The chelate holds it in the available form. But some of the chelates are themselves pH sensitive. So they get into our soil and our water, and the first thing that happens is this, the chelate deforms, and then the target molecule changes. This one remains plant available up through pH 10. So that's good. Pruning, not going to spend a whole lot of time here. It is a very important part of maintenance, but there's so much to talk about that it's really hard to throw it into a talk like this and do full justice. Basically, what we're looking at early on is we want to prune to strong form. We may want to prune a little bit to limit fruiting. If we take off some of the fruiting spurs, then we have less thinning to do in order to not have too big of a crop that breaks the tree. Pruning is often best done in late winter, early spring, right before dormancy breaks, especially if you're doing small cuts. The tree is about to come out of dormancy, about to be able to deal with the wounds, and you can see that structure really well. Midsummer is better for size control. It is harder to see what's going on. So these are some apple trees that were planted with all of the best intentions. I'm sure somebody said, we're going to have an apple orchard. And then they realized how much management that actually involved, and they said, we're not going to do that. And the trees grew for a while, and then they said, oh, we got to do something. So they came in and they pruned them. And then they let them grow back again. So this rash of growth that we see on the right-hand side is all pruning response growth that has come off of big topping cuts. And as such, it's too thick, and it's mostly all vegetative. So you have not done yourself or the tree any favor by going in, topping these thick branches, and then ignoring it. Now, if you just bought this, this is that 3 to 4 year process of selecting certain leads to keep, removing others, and then starting to shorten and broaden the ones that you keep. But you can't do it all at once. If you take out too much during a given year, you're going to force that tree to start basically feeding on itself for survival, and you'll put it into a starvation cycle. So any pruning cut that hits live wood has hurt the tree. It's wounded the tree, and there's kind of a couple of issues involved there. One, that interior wood has been exposed to decay spores. They're everywhere in the environment. They may get started on that wood and begin to decay the heartwood. And eventually that happens to all trees, eventually. We just don't want it to happen too soon. You may also damage that all-important cambium layer that's going to generate all new growth. And you have made a spot in the tree where energy is required for repair, but you've removed all of the energy-producing leaves closest to that point. So, bottom line, the correct amount of pruning is the least amount that gives you the results you're looking for. The picture here, I was practicing some grafting. This is a bench graft. Excuse me, not a bench graft, now I'm blanking on cleft graft. Anyways, you take a larger stem, you cut it off and split it, and then put a different scion wood. It's apple to apple still, and beeswax to keep it all from dehydrating. But that's a pruning cut that you might make. Dosage, I mentioned this, the standard rule of thumb is about 25%. If you've got a young tree that is really growing vigorously and has a major issue, take out more. The tree can deal with it. If you have an old tree that is struggling, take out less. The tree cannot deal with it. I've seen a number of trees where the only pruning recommended is deadwood, because every leaf that tree has, it needs desperately to try to keep itself going. Where you place that cut is very important relative to the architecture you're working with. We look for branch collars. We want to preserve branch collars. We look for branch bark ridges. We want to preserve those as well. Again, this is a whole topic in and of itself, so we're not going to do a deep dive on that. If you are removing bigger branches, however, I do definitely recommend the 3-step method. Basically, you make either an undercut and then an overcut, or 2 offset side-by-side cuts, so that you can break off and remove the bulk of the branch before pruning that last little stub. What that does is it prevents that pruning cut from getting overwhelmed by the weight of all of that attached wood and ripping into the trunk bark, which opens a door that cannot be closed. Pruning sealant, all the best research right now says it doesn't help. May potentially be a detriment. When we think about how that tree is going to deal with the wound, we often talk about trees healing, but tree tissue does not heal the way animal tissue does. What the tree tries to do is seal that wound up with anti-decay chemistry from below and new growth on the top, and then just keep going. In order to do those two things, the anti-decay chemistry, the new growth, the tree has to be awake. It has to be metabolically active. And to the extent that it is a stressed tree, it is not going to do them well either. So like everything, so much of this is keeping the tree from being overstressed. All right, I'm wanting to make sure I don't run, well, I've already run overtime, great. As long as y'all are still with me, we're almost done. Stupid people disease, I didn't coin this term, Dr. Curtis Smith. retired NMSU state horticulturalist is who I heard it from. These are things we do either intentionally or because we just don't know better that damage trees. So things like herbicide damage. Here we see in the picture some 2,4-D damage on grape leaves. Drift level, not severe, plant will recover. But sometimes things are done in a way that they don't recover. Let's just look at some more pictures. The pesticide issue, I'm going to get to that in a minute. Here is examples of trees damaged. Again, these are landscape trees, but they could have been fruit trees. These were in gravel type environments, and a particular combination of herbicides was used to control weeds and resulted in severe woody plant damage. Severe, maybe not recoverable. There we go. Oops. Here we go. Pesticide overuse. In my early days with the extension office as a horticultural agent, I was called out to a backyard apple situation. The gentleman said, you know, I don't know what's going on with my tree. The leaves are just getting all discolored, kind of bronze colored. What's going on? And you can see the discoloration, you know, in the middle of the canopy here, and then a close-up of that discoloration. So the real thing is that this gentleman, in a very vigorous and zealous endeavor to control codling moth, was spraying malathion. It might have been every other week, but it was very frequent. And I'm here to tell you he had no codling moth problem, but he had billions of spider mites on this tree because all of their predators had been wiped out by the malathion. And there are much better ways to control codling moth. That's not my topic. I won't go into it, but don't do it this way. This is not appropriate. Physical damage. If it breaks the bark, it threatens the tree. Like all damage and threats, the tree can survive some. It's a matter of when you reach a critical limit, and that's only knowable after the fact. Tree root damage is incredibly dangerous and often hidden. So we think about that a lot. The tree protection zone, this is at least the area under the canopy that really you shouldn't do anything to. Don't trench it, don't park on it, don't add soil, don't take away soil. The little graph on the side here talks about how much sand or how much soil you can add above roots before you damage them. And if you're talking about a clay soil, a couple of inches of additional soil and you've initiated massive root damage. Sand, you can add considerably more because it's a much looser soil medium. All right. And then poor planting. So another file from my early days with the Extension Service, you know, one of these North Valley Albuquerque properties, 2-acre front lawn, apple trees out there for the appeal, not for the fruit, just for the country look of it. So these people have money. They bought big trees, put in big trees. And I was called out to figure out what's killing this tree. So first thing I'm going to tell you is anytime you see a tree that the entire canopy is in trouble, look at the soil and the ground. That's where your problems are. And what we found in this tree was that when these had been planted, they were big ball and burlap trees. Nobody cut that poly cord that held the burlap in place. It does not break down, it does not decay, and the tree cannot break it. And it girdled the tree and killed the tree. We did find the same situation on other trees in the planting that had not yet started browning out. So hopefully they were saved. I never got a chance to go back and see the follow-up. Okay, that's it. That's all I had to say. That's my contact information, and I'm certainly available for questions.
Thanks, Joran. That was wonderful. I was jotting down notes. Learned a lot.
Yeah, there's a lot in there.
I loved it though. It covered everything from start to. Also, that's awful. Those apple trees was planted with the burlap.
Yeah, that happens more than you would like to know. And it's mostly landscape trees. Most people, especially if they're, you know, even a small scale commercial orchard, that's not a mistake they're going to make. But it's a mistake that landscape installation companies make every day.
Why? Do you know why that is?
Lack of training. They're getting new people all the time. Hurry up and go scheduling, and that's one thing I found moving out of the public sector into the private sector. In the public sector, I can take my time because I'm getting paid on an hourly basis. In the public sector, I may be getting paid by the job, or maybe I'm on the clock, but I've got somebody standing over me. Go, 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 go. And a lot of these companies will give you like a 1-year warranty on plant material. That didn't kill the tree in 1 year. Guaranteed to kill the tree, but not in 1 year.
But not in 1 year. So with those planting mistakes, like if someone's planted too deep or if there's the bag around it, can that be fixed?
Often it can. It kind of depends on how long ago it was planted. So if you planted some trees this spring and you put them real deep and you saw this, yeah, dig them up, lift them, make sure that the soil underneath the new level is compacted so it doesn't then settle. Do it as soon as you can after you notice the problem. Maybe you wait for the season to end and you do it while they're dormant, but don't wait more than 1 year. If it's been a number of years, it may not be very successful, but you may want to try anyways, just because back to planting too deeply, the most common result of that is not tree death, at least not quickly. It's a failure to grow. So that tree will sit there for 10 years and put on a foot of growth in 10 years. It's still there. It's still alive. Why isn't it growing?
But it's not, but it would grow taller if it was planted the right.
And certainly, it's not living up to expectations. Girdling roots, if you can find them and they're small, cut them. Take a chisel, little wood chisel, get them out of there. By the time that they have made a significant indent into the trunk, cutting them may be too late. That choke point is fairly fixed and new growth may eventually fill in, but is enough water going to get through in the meantime for that new growth to happen? And then a colleague of mine was making the comment that if that is so deeply embedded and you cut it, you may actually weaken that part of the tree because it has grown being supported by its own choke point, right? It's like those African tribes that used to put the neck rings on women and stretch their necks out real tall. And if you ever take that neck ring off, there's no muscles left here to support that neck. So you got similar issues going on there. Bottom line, though, is if these are really severe problems, try to fix them. What have you got to lose? If you kill the tree right away, great. Get it out of there, plant a new one, do it right, and you're off and running.
It's true. It's going to die at some point. Anyway. There was a question about compost. If you place compost around the trees, should you keep a space between the trunk and the compost?
So, and I'm going to address that both in terms of compost and other mulches. So compost around the tree, if you're using it like as an annual top dressing to feed the plant, you're not putting on very much. You might be putting on an inch or so. And in that case, if it's up against the trunk, it's completely irrelevant. It's not deep enough to cause any issues. If you're using it as a mulch, you might be going in 2 to 3 inches deep, and compost that deep right up on the trunk may stimulate the growth of some adventitious roots into that compost. Whether or not that's a problem, I'm not really sure, because there's some thought that, that root is going to grow into the compost and then become a circling root. But why is it necessarily going to circle? It may just keep growing out into the compost. But that said, I personally wouldn't use compost that deep as a mulch, because it's going to be exposed to sun and wind. A lot of it's going to dry out and blow away and not do you any good. Maybe you use a little bit of a compost under a wood chip. The wood chip is denser, thicker, heavier. it's not going to dry out and blow away the way compost would. Wood chip up against the trunk. There's a lot of stuff out there in the literature that says keep it off the edge of the trunk because, again, you're going to get rooting into that stuff, or the mice are going to hide in there in the winter and chew on the bark. I don't believe any of that. I have mulched this deep with wood chips up against the trunk of trees, and they've been fine, and they were small trees. First point is that adventitious rooting. In a much more humid climate, there might be enough moisture in that mulch to be hospitable for roots. In our climate, no, it's too dry. As for the mice, if they're hungry, they're going to cross bare dirt and chew on the tree. So I don't have a problem with 2 to 3 inches of mulch up against the trunk.
Okay, I suppose too, if you go out in natural environments, there's mulch right at the base of the tree.
Yep.
Also along the compost subject, is there a specific type of compost that's ideal for fruit trees?
Maybe, but I'm not sure what it would be. So the compost I would be wary of. 2 issues. One is sometimes composts end up with high salt levels. And so if you're seeing symptoms that match a salinity problem, it might be the compost and you might want to switch composts. Another problem that has occurred periodically with compost is herbicide damage. And the way this happens is there's a couple of herbicides that are used for hay production. They are broadleaf herbicides, so they don't hurt grasses, but they hurt broadleaves. And these particular chemicals do not break down in a compost process. And so either they're coming in because maybe you got some spoiled grass hay and added that to your compost, or you used manure from animals that ate the treated hay. The chemical doesn't break down in the digestion. It doesn't break down when it comes out as manure. It doesn't break down when it gets composted. And you'll get tree damage that way and plant damage that way. So, the best compost, if you can make your own out of a variety of ingredients. But beyond that, it's like I used to say about using manure for, enriching soils and whatnot. The best manure is usually the manure that is cheapest and easiest to get a hold of. That's the criteria.
That's the best.
So if I got to drive 50 miles to get compost that maybe is arguably a little bit better than the compost I can drive 5 miles to get, I'm going 5 miles.
Right. I like that. Well, I was thinking we could email you other questions, and then
I'd be happy to
put together. We'll put together a little Q&A from all of our sessions.
Okay.
By topic, if that's okay.
That sounds great.
So thank you so much, Joran. That was wonderful.
Well, my pleasure, and I hope you all got something out of it.
Yeah. I think we all did. Thank you.
All right. Take care.
Bye.
Bye-bye.